All right, so multiplying monomials. The first question I have for you is, what does the word mono mean? What does the word mono mean? Remember, we had binomials, which was 2, trinomials, which meant 3. Yes?
Emma?
Emma? Mono means? 1. Yeah, it means 1. So 1 and nomials, meaning terms. So these are 1 term. So in other words, we're multiplying 2 things together. Here's one thing, and here's another thing. And each of these have 1 term. In other words, there is no addition or subtraction sign inside the parentheses. So all of these are monomials. Even though this has A's, B's, and C's, it's still a monomial because it is 1 term. There's nothing being added or subtracted inside that parentheses. This, on the other hand, is a binomial because we have 2 terms. 1 term, 2 terms. So this week we are going to be multiplying a monomial times another monomial. All right. So the first question I have for you is, we have m to the 3rd. What's another way of writing m to the 3rd? How would I write m to the 3rd in exponential, or sorry, in expanded notation? Jake? Yeah, because m times m times m is in fact m to the 3rd. All right, what's another way of writing, and we're multiplying m to the 3rd to m to the 4th. So what's another way of saying m to the 4th? This is not a trick. Olivia? Okay, so if I'm multiplying m times m times m times m times m times m times m, what's another way of writing this in exponential notation? How many m's am I multiplying together? M to the 7th power. There you go, m to the 7th power. So m to the 3rd times m to the 4th is m to the 7th. So I want you to take 15 seconds, and in that 15 seconds, I want you to ask yourself, what are we doing with these exponents, 3 and 4, that got us 7? 15 seconds should do the trick.
Wiley.
Wiley? What? Wiley, not Riley. What did we do with 3 and 4 to get 7? I added them together. That's exactly right. So the rule that you're going to be using is, and on the outside of your folder, you should start writing these rules. There are about 6 of them. So this is a good time to start that. And this is multiplying monomials. And the actual algebraic rule is if I have 2 bases that are the same. In other words, a and a are the same, and I'm multiplying these things together, I will add the exponents. So a to the x power times a to the y power is equal to the a to the x plus y power. And that looks far more complicated than it really is. Essentially, if you have the same base, you just add the exponents together. So let's try a couple of really quick examples. All right. Since it is your birthday, what is Sarah to the 3rd times Sarah to the 9th? Using the rule of multiplying monomials. When you know the answer, go ahead and shout it out. Sarah to the 12th. All right, let's try another one. This time I'm going to be a little bit trickier. I'm going to be devious. Dastardly, even. Let's say we have Sarah to the 10th times Sarah to the negative third. What will I have? 0 to the 7th. So it doesn't matter if we have negative exponents, the rule still applies. Okay. Let's try another problem for something a little bit different today. Let's go with Sarah, lay me to the 4th, times Sarah to the 3rd, lay me to the 9th. So we actually still have two monomials. Sarah, lay me to the 4th is a monomial. Sarah to the 3rd, lay me to the 9th is also a monomial. And notice how the 4 is only right next to the L, which means only the L is getting to the 4th power. The S, what power is the S to? What power do we not need to write? First, right, yeah. So, all right, so given this situation, what power will my Sarah's be in this problem? Sarah to the 4th, because 1 plus 3 is 4. Okay. How many lamies do we now have? 13. Thank you. All right, Sarah, do you mind sharing with us your middle initial? You don't need to give us your name. Just your middle initial. Okay. So it's the Germanic, not the British. All right. So let's say we have Sarah to the 2nd, Catherine to the 3rd, Lainey to the 4th, times Sarah to the 11th, Lainey to the also to the 4th. All right. So I'd like you to try to multiply this one together really quickly.
Jacob? Oh, maybe you stretch it.
Jacob, do you have the answer? Okay. Sure. I'll ask you in 30 seconds. Okay, well, actually, I have a better idea. Jacob, why don't you pick somebody to share with their answer? We're adding, hold on a second. We're adding the exponents. We're multiplying the monomials, but when you multiply the monomials, you will add the exponents. There you go, 13th, all right. That's right. So again, we multiplied these monomials together. When you multiply monomials together, it's like adding the exponents, and we proved that right here because we had m to the 3rd was m times m times m. M to the 4th was m times m times m times m times m, which meant we had 7 m's multiplied together, which is the same as adding the exponents. Okay, and we had a k here, we had no k's here, which meant we just had k to the 3rd over here. All right, so given that, I would like you in 60 seconds to do the next two problems. 60 seconds for the next two problems. Okay. And Margaret, everyone better be nice to Margaret, because she is going to be doing the next section. I have no self-control.
Do I need to take them away from
Yeah, I'll take them. Well, if you can't overbuild it in corner. in the October teens.
This is true.
You say that one more time? Yes, F to the 9th, G to the 1st.
Oops.
Oh, something stuck in
Candy corn?
Okay. Alright. All right. Raise your hand if you got that answer too. Oh, yeah. Okay. In the second monomial, yes.
It's a 9. It's just
Well, in the ABC one, it's a 6. You're welcome. Okay. Margaret, would you please pick a boy for the FGH problem? Just pick it away. Of course.
for a boy, yes, he's the only one reason.
All right, Avery. That's a 2. It's okay. F to the 11th, G to the 3rd, H to the 1st. You don't have to write to the first power. Okay.
Emma has her hand.
Yes, Emma. Yes, you can say that, you can rewrite that as A to the 1st. Yes. Up until this point, really, you've only had variables that were to the first power, and any variable to the first, or any number to the first power is just that number. So that's why you don't have to write to the little exponent 1 next to it. All right. So there we go. So for today, we are going to be looking at growth patterns in exponential functions and how they show up in the table, graph, or in an equation. And we're going to spend 2 days on investigation 1.3. 2 days. The homework assignment sheet has been updated and is in the Schoology homework assignment folder. I have not created the multiple homework assignments in the actual folder yet. So look at the homework assignment sheet if you want to start your homework early. All right, so making a new offer. The last time we talked about the king and his little boy, he had been duped by the peasant into giving her a reward that was more money and more land than he could possibly give. And so he goes home, he doesn't know this yet, he goes home and he tells his wife, the queen, what had happened that day, and she looks at him, because she's no dummy, and she says, "You idiot! You've promised more money than we have. You have ruined us. Go to your room and come up with a plan that she'll accept that we could actually pay. And so the king got sent to his room. It's very embarrassing when you're an adult and you get sent to your room by another adult. All right, so he needs to come up with a different plan, making a new offer. And so here's the king's plan. The king, after much thought, is not the most original person in the world. He says, well, everything looked good for a little bit, but then it just got out of control. So here's what we're going to do. I'm going to give her a 16 square chessboard. So how many squares are on the king's board? 6. No. The peasants is 64. The king's is 16. But obviously, if he gives her a 16 square chessboard and doubles the pennies every time, it's obvious she's not going to make very much money. And he needs to convince her to take his plan. So you know what he decides to do? Instead of doubling, he is going to triple the number of pennies on each square. So how many pennies are on the first square? 1. How many pennies will be on the second square? 3, because his triplet. You know what? You know what I smell? Table. Do you smell that over all the way in Grand Lake, Charlie? I think you might. I smell a table too. Okay. So we are definitely going to need a table. Oh, look, a table. Shocking. All right, so plan number 1. Plan number 1 is the peasant's plan. Let's see what we have this here. So let's make a table. Get rid of this. All right. So plan 1 is the peasants. And I probably misspelled that, and I don't care. And how many squares are on the peasant's plan? 64 squares. And if I'm writing, what should you be doing? Writing, okay. 64 squares. And how is the growth happening? How is this growth happening? It's doubling. Okay, so the peasant's plan is doubling. And so we have square 0, square 1, 2, 3, 4, 5. I'm not going to go past square 5. All right, and on the first square, how many does the peasant have again? 1. And actually, the king has 1 also. How many squares are on the peasant's plan, or how many pennies are on the second square in the peasant's plan? How many are on the king's plan on the second square? 3, because his tripling. Okay. How many are on the third square for the peasant? Yeah, 4, because we're doubling. How many are on the king's plan? 9, because we're tripling. Okay. On the fourth square, how many will there be for both? 8, and then for the king's plan? For the sixth square, for the fifth square, how many for the 16? And how about this one right here? 1. All right. Notice how I'm going to leave space for 2 more squares. And my information on those two last squares are it's going to be a little bit bigger, so I made them bigger squares. All right. So the king goes to the queen. This is my plan. And he tells her the plan, and she looks at him and says, "Not good enough. Not good enough." So you know what she does? She comes up with her own plan. And here's the queen's plan. The queen is unconvinced by the king's new plan. She devises plan 3 and uses a board with 12, that's right, only 12 squares. And she is going to write the equation r, in other words pennies, we're going to use a p for pennies, is equal to 4 to the n minus 1 power. All right, so let's go back to this. All right, so in the king's plan, how many squares? How many squares in the king's plan? 16 squares. And what is the king doing? What is the growth pattern that we see? Triples. Yes, these are all exponential. These are all definitely exponential. All right, for the queen's plan, that's plan 3. How many squares does she have? 12 squares. And you definitely need to keep track of all of this stuff. And we don't know her growth rate yet, but she gives us an equation. And so if we have square x, she will have the equation pennies is equal to 4 to the x minus 1 power. And we had, well, what was the equation for the queen, or sorry, for the peasant? Does anyone remember what? And what was the base there? Or we also had 1/2 times 2 to the power of x. All right. Okay. So based on the queen's plan, what is the growth? How is her plan going to grow? Okay. So what are we multiplying by every time? 4. So this is quadrupling. So we are quadrupling. All right. So how many pennies will be on the first square of the queen's plan? 1. We're going to start with 1. Okay. How many will be on the second square if we are quadrupling? Quad meaning 4. 4. All right. How many will be on the third square? 16. How about the fourth square? Now you're counting. 64, excellent. How about on the fifth square? 256. All right. Okay. Based on the equation of the peasants and based on the equation of the queen's plan, what would the equation be for the king? Okay. Or how else could I write it looking at this? One-third, nice. Okay. How about the queen's plan? How else could I write the queen's plan? All right, excellent. What is the y-intercept for the peasant's plan? if I follow the pattern backwards, how many times would be on the 0th square? So what do we do to 8 to get 1/2? Because we divided by 2. Okay. What's the y-intercept for the king's plan? 1/3. All right. What's the y-intercept for the queen's plan? 1/4. Oh, check that out. 1/2 is the y-intercept, and it showed up in the equation. 1/3 is the y-intercept for the king's plan. It showed up in the equation. 1/4 is the y-intercept for the queen's plan, and guess where it showed up, folks? It's like, I'm glad that you're here, Karen. Otherwise, I feel like I'd be all by myself.
I know. And no one's even raising a hand.
I know. It's Monday. That's what I'm gonna blame it on. That's right. We're going with the Monday excuse. All right. So yes, it is the y-intercept. It is definitely the y-intercept. All right. So we have these 3 plans. We're gonna get a 4th, but we're not going to do that today. We have 3 plans. Everyone should have this table so far. And if I look at question A, oh look, we're to make a table just like we started, and we're going to start at 0 square. The 0 square, you got to start with 0 in the table, and you're going to go to the 10th square. That's right, from 0 to 10. For question B, write an equation for the relationship. We did most of that. Make a graph for plan 3. I actually want you to make a graph for plan 1, 2, and 3 on the same grid. So how many curves will you have on one graph? 3. All right. Your graph, I only want your graph to go from squares 0 to square number 6. So what is the what is the domain of your graph, or the x values? What is the domain of your graph? And 6. And don't forget 0. 0, 1, 2, 3, 4, and 5. So we have about 10 minutes left. I would like you to go to your common rooms, and I would like you to start making your graph of all 3 plans. 3 different colors would be certainly advisable. You sound exasperated.
I am. 6th grade has 7th grade on the ballot.
I think I should go with my idea. You can have it right next to a bottle of Clorox wipes, the dry erase marker. And so as soon as you don't wipe off, put it back on the chalk tray and sit down. If the dry erase marker is gone, you have to wait.
So,
Whose idea was this?
the sports heavily do it.
That sounds very pointed. Some things that work for elementary.
Yeah. I'm letting her know that 16 of them. 5 are messed up, 8th grade cut wrong. And then I can't remember how many I counted, 15.
You can blame it on me, but you can say, dear Miss Ford, Mr. Granke has an idea that might be a little bit easier.
Except she's already bought all this later. That's good to see. Shelby Sandberg, 6th and 7th grade. Oops.
Okay, I kind I feel like that black sheet and all, but it will be much better if they ask you. So you think we're unorganized, or what's happening? This is parent-teacher conference week, and South teachers still haven't been told how they're supposed to do parent-teacher conferences.
Oh, really?
So my texts have been blowing up because the coaches are.
Here, I only found out how to do it. In South is high school.
Yeah, so 0 to 6. Who are you spending your birthday with, Mia Fitzpatrick? No, I know that.
My microphone isn't working on my computer.
Actually, it's pretty funny because right where you're sitting, it's Mia's name is right underneath your face, so it looks like you're labeled Mia Fitzpatrick. Does everyone else see that? Am I the only one who finds humor in it? Thanks, Ford. I love you too. All right, how are your graphs coming, girls and boys? All right. No! Okay, I got a laugh out of somebody.
You did.
Ford, one grid with 3 different lines on it, okay?
Different colors, too.
Different colors would be good. Yeah, what's up? Why on earth would you want to mute me harassing your classmates? Oh, because what you have to say is more important than what I have to say? The answer to that is clearly yes. You're welcome. Glad that you did this. You don't?
Happy? Neighbors? Where is your name?
Hello? So we have Walter and Clara. Clara, you are there wicked early. I applaud your priorities in getting out of your first period class, which must have been very boring, and getting the math quickly. She didn't have to know I said that.
No, I'm not telling you. I don't tell nothing. I hear nothing.
Hey Pascal, I got your retake.
Owen's back too.
Pascal, just out of curiosity, do you need a Chromebook with a camera on it? Because I can help you with that. Okay. Obviously, you were just by the school earlier today. Are you going to be near the school any other time? Because we can give you a Chromebook with a camera that functions properly. Okay, because I feel bad that no one can see your face. You see, if you're done with the graph, then we're going. Actually, I'll say this out loud for everybody. All right, so guys, you have to have your graph finished by class tomorrow. So if you don't have this graph done by now, that is part of your homework. I've split up the homework assignment that was meant for one day into 2. So your homework should not be super long anyways. So I don't feel bad by telling you to make sure the graph is done also. Okay? So, and by the way, Miss Stoddard's class is, let me just put it this way. Period 2 is showing up early to math class, so have fun with that. All right, so have a wonderful day, and I will talk to you tomorrow about the plans, and we're going to add to it the financial advisor's plan. And it's going to be super interesting because the financial advisor's plan is the reason why you had a teacher strike the other year, a couple years ago. Yep, it's a true story. This investigation, true story, is this investigation explains why there was a teacher strike 2 years ago. There's no social studies? What? Well, actually, that was a birthday present for you. But aside from that, there was a mathematical reason why there was a teacher strike. Mostly having to do with the school district was trying to cheat us, and teachers are stupid. Oh, I shouldn't have said that out loud. Okay, thank you. Okay, goodbye. Teachers are not.
Unless they teach it.
Unless they're the teacher. That's very true. The irony is, when it happens, I mean, I've been teaching this investigation for years. And they did the exact same thing that this investigation is trying to do. They gave a little table that only shows the first 3 years. Look at this great deal.
Did you show them?
Oh, I did. I felt kind of bad for the guy because I'm glad that you get to hear my story. The poor guy. Well, you'll hear the whole story tomorrow.
Yes.
Suffice to say, he didn't know what he was doing. He was just hired to sell documents. Here's how you sell it. He went out and sold it. I assume he kept selling it after.
I'm sure you
I'm sure he did because it was a job. All right, guys.
Correct.
Oh, geez. This is a long video. I'm going to stop the video.